Hi, everyone. I'm Motion Mike Miller, and I'm a solution consultant with Rockwell Automation. Welcome to Motion Minutes, where we dig into the features of our integrated motion solution and discuss how they can save you time and money, differentiate your machine, and provide higher performance to your customers. In this series, I'm just going to be focusing on our modern servo drive offering. Our Logix integrated motion solution and the features presented in this series are specific to the Kinetix 5300, 5500, and 5700 drives that you see on the screen. So for the first 30 of my 35 years in motion control, I've really spent a lot of time helping customers with tuning challenges. The problem with tuning is mechanical inefficiencies, loads that change. These are the reasons why they would bring Motion Mike in to help with the systems. If you've got a good stiff system, well built, and the load never changes, then maybe auto tune one time and you're ready to go. But let me tell you about some features that are already in place, already turned on, that just may save you some time again on your startup and commissioning efforts. So let's say you've got a load that's simple and straightforward and you auto tune. Okay, maybe not a lot of advantage for me to help you with the tuning list features there, but stay tuned, no pun intended. So let's say that you've got a system that goes out with a heavy load and comes back empty-handed. Maybe it goes unstable if you tune it for the heavy load, so you detune it so that it compromises on the heavy and the empty move. Not optimal. It's going to increase your settling time and maybe make the cycle time, longer than it should be. So then maybe you decide you're going to artificially program some magic in the tuning to where you tune it hot going out and you tune it low coming back. Again, that's effort. That's things you shouldn't have to do. And finally, let's talk about a winder, where you go from an empty roll at very high speed, center driven, all the way up to the full roll with gigundous inertia mismatch, but very low speed. Maybe you have to write code to continually tune that system for every so many revolutions or so many layers. Wouldn't you like to not have to do that? So I'm going to introduce some topics, some capabilities that are in our products today, and they're actually turned on by default. So if you're manually tuning today with our modern servo drive solution, you're actually turning these features off, and they may save you time and effort. So let's get into those. Let's first talk about manual tuning. So we do the auto tuning. We've got a system that isn't optimal, and maybe it makes this horrendous noise when you tune it, and you're not happy with that. So to make it high performance and stable, you kind of compromise on the bandwidth. You lower the bandwidth. This is what we've done historically. Now you've compromised. It's not running at full bandwidth, but that's what you get, right? Because it's going to make this horrible noise if you don't do that. Well, that's the old way of doing it. So Load Observer is an auto tune in real time without you having to do anything. Again, it's turned on by default. Load Observer listens to the drive 8,000 times per second and answers with suitable system bandwidth. And so, for instance, in that story where you go out full and you come back empty, Load Observer is going to tackle both those and leave you with high performance. And then the winder, again, it's going to continually update and auto-magically, effortlessly tune that winder for optimal control. But however, it's still going to have a high-pitched whine to it. So now let's address that. Here we are showing that same tuning rig with multiple inefficiencies. And it's running high performance, but it's got the flute tuning, the fifth grade flute tuning going on here again. So it's kind of that high-pitched squeal. Well, there's another feature turned on by default in our modern drives called adaptive tuning. And adaptive tuning works in the higher ranges to make the system stable. So you got Load Observer making it high performance, and you got adaptive tuning making it stable and getting rid of that ringing sound. It's turned on by default. So again, if you're still manually tuning these systems to get around those, you're probably lowering the performance of your machine. So what I'm going to encourage you to do is to enable, to not tune the system manually. Just let it tune itself. It'll squawk for a brief second on enable, and then it'll never make that sound while it's running for the rest of the time, because it's constantly listening and adapting the notch filter frequencies to make it high performance and stable. I've walked out and showed customers this, and they're always astounded that we have this capability and they didn't know about it. So reach out to your locals for more information on that. There's also a helpful tuning guide. So for instance, if you've already tuned the system and you need to detune it, to untune it, and put it back to factory out of the box specs to leverage the load observer and adaptive tuning, there's a section in this manual that can show you how to do that. Finally, some advanced features that I'm really guessing you don't know about. Let's say you've got a system that has some slosh. You're controlling some liquids and you want to be able to move it quickly, but it's sloshing everywhere. Or let's say that you have to wait for a pendulum effect to stop before you can place something. That could be true on even robots, right? We have another feature called command notch filter. So I'm going to show you some quick videos here. This is without the command notch in place. You can see it sloshing. Maybe you have to wait, increase your cycle time. And then if you enable the command notch filter, which is part of the tuning guide, let's show you the next video here. It's going to offset that move and make it so it settles very quickly. Did you know we have this feature? Command notch filter. So what you do is follow the tuning guide to understand how to implement that. Basically, you'll go into Logics and you'll use a stopwatch to time the pendulum effect or the slosh effect. You'll put in a notch filter and cancel out that portion of the disturbance. Pretty cool. And then finally, for the really advanced crowd, no. What if you could have, you hear about AI, you hear about Guardian AI specifically in our Power Flex drives, and it's coming to Kinetix. But for now, we offer something called a virtual torque sensor. What if your machine were so smart that it could tell your end users about a jam or maybe belt tension problems or maybe some gearbox failure, pending gearbox failure, way before it ever happens? And we've all seen that motor shaft that's been broken off due to misalignment. What if somehow that happened in the field, but your machine was smart enough to tell someone there was a problem? So we offer this feature called the virtual torque sensor. And what it does is it takes the very hairy torque signal and filters it down to something that we can manage, a nice fine line that we can manage. So I'm going to show you here with the virtual torque sensor turned on. The blue line is a lot less scary to deal with and maybe more discreet in terms of taking action than that red line. So then you would use an add-on instruction to monitor that blue line. And when things go out of spec, we have different add-on instructions that let you know that it's a misalignment, that it's a possible gearbox because of the signature of the torque feedback signal. So first you would use 2198 AT003 to know how to configure the virtual torque sensor, and then you would use our add-on instruction available from our sample code website, all spelled out in the guide here on the screen, to help you implement that and add some super high value to your machinery and differentiate your machinery and your installations. Where can you learn more? Well, work with your local Rockwell folks and your distributor folks to take a hands-on lab in the cloud. We have an advanced lab that goes through the tuning list features, as well as the virtual torque sensor, and many more topics that we're going to be talking about. And of course, don't hesitate to download the motion system tuning guide and stop manually tuning things. Let the Auto Magic tuning list features do the job for you. Thank you for your time. I hope you enjoy this series. We got a lot more coming, so I look forward to talking to you all.